Assalamualaikum to my panel, Dr. Junainah binti Sadi and Dr. Intan Azmira binti Abdul Razak. I am Muhammad Hamizan bin Muhammad Isa from BEK GS1. Would like to present about my final year project, which is electromagnetic compatibility study of smart grid equipment within substation due to switching disturbance. I would like to explain about my introduction of electromagnetic compatibility. Electromagnetic compatibility, also known as EMC, is the ability of electrical equipment and systems to function acceptably in their electromagnetic environment by limiting the unnatural generation, propagation, and reception of electromagnetic energy, which may cause unwanted effects such as electromagnetic interference (EMI) or even physical damage in operational equipment. Next, the aim of employing EMC is to ensure that a variety of different items of electronic equipment can operate in close proximity without causing any undue interference. Next, I will go to the problem statement of my project. There are several problem statements for my project, which is the first one is within the substation environment. All equipment are exposed to the electromagnetic interference. Thus, the compatibility of equipment in the smart grid substation need to be ensured. For example, the current transformer. The second one is disturbance of EMC could come from many sources. One of them is from switching operation. And the last one is it is important to study the ability of current transformer within the substation compatibility level due to the magnetic field. Next, I will explain about my project objective. My project objective are the first one is to model the equivalent circuit of current transformer. The second one is to analyze the transient current during normal operation and switching operation. And the last one is to calculate the magnetic field due to the switching current of equivalent circuit current transformer. Next is the scope or limitation of my project. The first one is the study aim to investigate about equivalent circuit of current transformer with rated current 2000/5. The second one is the calculation will be focused on current transient and magnetic field of the current transformer. The third one is all simulation will be using MATLAB Simulink for simulation. And the last one is the study of current transformer in switching process will be regarding their electromagnetic compatibility with disturbance that occur. So next we will go to the literature review. I will explain more detail about my literature review. The first literature review is about electromagnetic compatibility. Electromagnetic compatibility issue on component and equipment in the smart grid system are exposed to a wide variety of regulated and radiated noise sources that are harmful to all electrical structure. Based on MEWG stated that EMC is related to electric power quality in terms of the level of certain EM disturbance that may exist in the environment such as interference phenomena or disturbance. But other researchers say that high or low voltage equipment coexisting in smart substation has led to the complexity of this substation electromagnetic compatibility. Hence, there is need to study on electromagnetic compatibility within the substation in smart grid using different type of parameters. The second literature review is about the equivalent circuit of current transformer. The general equivalent circuit of current transformer should contain the primary section and the secondary section combined with the burden. The first researcher said that the current transformer primary winding is connected in series with the device in which the current is to be measured. Since the current transformer is fundamental a transformer, It transmits the current from the primary to the secondary side inversely proportional to the turn, so as IP equals to NIS. But the other researchers said that the CT with the primary winding consisting of N1 turns and the secondary winding consists of N2 turns. The nominal transformation ratio equal to ratio of turn number N is equal to N1 equals to N2. The third literature review that I searched is about the transient current of equivalent circuit current transformer during switching operation. The switching transient current are mainly dependent on the current transformer response. The first researcher said that the transient current creates serious mechanical damage that may bend or destroy the transformer. But the other researcher proved that the transient waveform measurement on CB operation test result in 220 kilovolt substation shown in the picture below. Next is the literature review is about calculation of magnetic field. Magnetic field in the substation area are using common numerical methods such as finite difference and finite element, mostly due to the large scale of the electromagnetic problem to be resolved. But this researcher used the Biot-Savart law directly because of its simplicity and computationally efficiency. The formula is H equals to 1 over 4 pi lambda L dL times R over R squared, where H is magnetic field, I is the current, dL is current element of length, and R is the radius. So with this formula, I will find to calculate the magnetic field of my equivalent circuit of current transformer. The last literature review is about the standard electromagnetic compatibility. To ensure the device or equipment operate within the optimal compatibility level, compliance with magnetic disturbance, it must comply the standard requirement by IEC 61000. IEC 61000 refer to the immunity specification of device only under operating circumstances to magnetic interference at 50 Hz and 60 Hz power frequency relating to residential and commercial location, manufacturing facilities, and power plants, medium voltage and high voltage substation. Now we will move on to the methodology. So this is my flowchart of my project. I started by doing literature review regarding my project. After I do for my literature review, I started to model my equivalent circuit of current transformer using MATLAB Simulink. After designing the circuit, I run the simulation of my circuit. Then, if I get the output, I will analyze the result. But if I don't get it, I will do change for my equivalent circuit until I get the output for my normal operation and switching operation of my circuit. After I analyze the desired result, I will proceed to my calculation of the magnetic field for my circuit by using switching current. So this is my equivalent circuit of current transformer simulate using MATLAB Simulink. The circuit is present the equivalent circuit of current transformer. The parameter that I change in this circuit for normal and switching operation is the switch at the secondary winding. As you can see, for normal operation, it does not have switch at the secondary winding. But for switching operation, I do inject the switch at the secondary winding for t equals to 0.1 second. Next, I will show my preliminary result of my simulation of transient current for both normal and switching operation. This is the result from normal operation, as the first graph is for primary current The second graph is for secondary current, and the last graph is for the CT flux. And this is the result of transient current during switching operation. As you can see, the switch connect at t0.1 second, and this is the graph. And for the disconnection switch at t0.1 second, this one is the graph. The discussion of my simulation of transient current for switching operation that I made is when the switch is connected at t0.1 second, the current takes 0.001 second to flow in the secondary winding circuit. And the second discussion is when disconnect switch at t0.1 second, there is still have current flow in the secondary winding about 0.005 second to disconnect completely, and the current is about 3.5 ampere. The conclusion and future work of my project is the first one. The equivalent circuit of CT have been created using MATLAB Simulink. The second one is the analysis of transient current during normal and switching operation have been analyzed. And the third one is the magnetic field of equivalent circuit CT will be calculated in the future work. And last but not least, this is the reference that I cite for do my literature review. That's all for me. Thank you.